Hello students, today we're going to be looking at geometric construction, and this is available on page 20 in your textbook through to page 26. That's the section of work we'll cover today. Alright, so I'm going to be demonstrating each of these techniques, and you need to go and practice them all on your own so that at the end of this you will know how to do constructions when we get to the more complex drawings that require these techniques on them. So the first technique I'm going to be looking at is bisecting a line. So as you can see, all of our drawing equipment has measurements on it, and this allows us to measure off millimeters or centimeters or meters depending on the type of measurement that we're using. But in geometric construction, what we're trying to do is construct these things without actually measuring them. So if I had to draw a line, as you can see there, which has a certain length, and I want to find the center of that line, but I don't want to measure the line and then use the numbers to calculate the center and measure it again. I want to rather use geometric construction techniques to find the center. For this technique, we're going to be using a compass. As I said before, you have to use an accurate compass with very fine adjustment and a sharp pencil lead in it. So what we do is we take our compass, we put the center point on the one end of the line. Let's just label this A and B, so we know which end we're talking about. So we put our center point of the compass on point A. We need to then adjust the compass length so that it goes beyond the center. So that looks more or less like the center, but we're going to go further than that. Any random radius, not relevant at this point. Then we're going to draw an arc. So the arc needs to extend above and below the line, leaving our compass at the same radius. We want to place the point on the opposite end at point B, and then we once again draw an arc, but now this arc needs to intersect with the one that we've just drawn. So this gives us point C and point D. So there you can see those intersection points. Now we can take our ruler and join point C and D, draw a line between them, and that would give us the center point. Let's call it O. So that point O is at the center of A and B. So if we had to just check by measuring, you see that's about 51.5 millimeters. That should be 51.5 millimeters as well. All right, that's the first technique, bisect a line. Technique number one. Number two is to bisect an angle. And for this, I'm going to draw two lines starting at a common point at any angle from one another. We call that point B, we'll call that A, and that will be C. So we want to draw a line. Bisect means cut in half, so we want to draw a line that goes exactly halfway between those two, and we don't know what the angle is. So we can do that using geometric construction. So we take our compass, we place it on point B, which is the midpoint, the middle point of that angle, and we don't want it to be too long, about halfway along the lines, and then we draw an arc. All right, so now we can leave the compass at the same angle or the same radius, we place it on A, B, C, D, and F. I'm not sure where E is, but there we go. Now we place it on D, and we draw an arc along the middle. We place it on F. We draw another arc, and let's call that point E, seeing as we don't have an E. That point would be along the bisector. So we join B and E. And now that angle equals that angle. So angle A is equal to angle B. And if we had to take our protractor and measure that angle, we would find that it is 18 degrees. And if we measure this one, we should hopefully find roughly the same angle. That looks like 19, but that's close enough for this demonstration. Okay, that's bisecting a line and bisecting an angle. The next thing we want to do is to draw a circle to pass through 3 given points. All right, so let's choose 3 points. Let's look on this side. I'm going to draw a point there, which we'll call A, a point here, which we call B, and another point here, which we call C. We'd like to construct a circle through those 3 points. So the first thing we do is we join those together. We join A and B, and we join B and C. To the center of those points. The next thing we do is to bisect each of those with a perpendicular line. Now what we're actually trying to do is to find the center of a circle. In order to draw a circle, you always need to know where the center is. So we can place our compass point on that and draw the circle. So we're actually constructing the center point of this circle. So to do that, we are going to draw a perpendicular line that bisects A and B. So it's very similar to what we did when we bisected a line. We'll draw an arc from both sides with our compass set to a radius that is just greater than halfway. All right, so now we've got 2 intersection points which will give us a line that bisects and is 90 degrees actually to AB. Let's do the same with B and C. Maybe change the radius so that it's easier to identify. And here we can see that point and that point over there. So now we have a perpendicular line going through the center of B and C. Now the interesting thing is, if we look at that line, we'll see that it intersects with the other perpendicular line. And that is going to give us the center point of our circle. So all that's left to do is put our compass on that intersection point, set it to one of the distances, and we will find that the circle will then go through A, B, and point C. All right, that worked out very well. So that is how to draw a circle that passes through 3 given points. The next exercise is to erect a perpendicular from a point in a straight line. Alright, I'm deliberately not using the ruler so that you can see we are only constructing these lines. So I'm going to draw a line. Let's call the end point A, and then we have another point C, and B is at the end. So what we'd like to do is draw a line from C going upwards that is perpendicular to AB. Alright, so we're going to put our compass on point C. Then we're going to set the compass to a given radius, which is CD. In other words, that is D. Without changing the radius that we've set it to, we now take our compass and put it onto D, and we mark off the first distance where it intersects with that radius, point E. We place our compass on point E and mark off another point, which is F. Now we can place our compass on E and draw an arc above E and F from both sides. So there's F, an arc from both sides. You see, I didn't change my radius on my compass from C to D, so that distance, all of those are all the same as CD. Now if I had to connect to point G from point C, that would give me a perpendicular line from that point to C. So I've now constructed a perpendicular line from a point on a given line AB. All right. Then we have the next exercise, which is to drop a perpendicular from a point to a straight line. Drop a perpendicular. All right, let's just draw a random line, AB, and then we decide that we would like a perpendicular line, but it must be from a point that's not on the line. So let's choose a point out here as point C. So from there we'd like to drop the perpendicular down to AB. All right. So what we do is put our compass on point C and we draw an arc that will cut AB in two places. So it's going to cut AB at D and E. Then we're going to place our compass on point D and draw an arc below the line and at E, and draw another arc below the line to find an intersection. That would be point F. If we now draw a line that connects F to C, that will be perpendicular to AB. So that way we've been able to construct a perpendicular from a point that is away and above the line. The next exercise is to construct a parallel line to any given line by construction. Alright, so this is pretty easy. We've got a line here, let's call it AB. And instead of going and measuring with our ruler, what we're going to do is set our compass to a measurement. So let's measure on the compass, let's measure 30 millimeters. Set our compass to 30 millimeters. We want a perpendicular line that is 30 millimeters from AB. So pick a point on the line, draw an arc, pick another point, draw another arc, and so on. Right, straightforward. Now we have to draw a line that is tangent to those three arcs. You can just see the pencil mark sticking out there. So we draw a line that is tangent to all three, and then that means that this distance will be 30 millimeters and parallel. Those two will be parallel to one another. All right. The next exercise is joining two straight lines by circular arcs. All right, so we're trying to create a radius from two straight lines. So we have a straight line here, and a straight line there. And we'd like a radius of, say, 20 millimeters that joins those two. So to do that, let's just measure 20 millimeters on our compass. Set the radius to 20 millimeters. Now we can do similar to what we've just done and draw some arcs. But in this case, we're going to do it on both lines. Alright, so that allows us to draw. I didn't quite finish that arc. Allows us to draw our tangent lines. Offset at 20 millimeters. Now we have an intersection point over there. That will actually be the center line of our arc. So we put our compass on there. It's already set to 20 millimeters, and we can just draw the arc that blends those two lines together. Doesn't matter what angle you're drawing that at, you can still do the perpendicular lines. All right. The next one I want to show you is, this one is pretty similar to that. So let's have a look at this bottom exercise here, which is pretty important, as we're very often joining two circles with an arc of a different radius. So how do we construct that? All right, and I think I need to just put that on a fresh page. So I'll flip this over. So I've got some more paper to work on. Alright, so let's draw two circles with a known radius. So we set our compass to, let's say, 30 millimeters. and we draw a circle. There's the center point, and this is radius 30 millimeters. Let's draw another circle with a radius of 50 millimeters. At another point. So this is a radius of 50 millimeters. Alright, what we'd like to do is draw an arc that goes at the bottom, that is facing upwards, and that joins those two, and that must be a radius of 100 millimeters. So the arc well, let's make it 80 millimeters so it doesn't get too big. So that arc must go here. Now we want to find the center point of that arc. So the way we do this, we know that if the arc is going upwards, the center point will be below it. So therefore, somewhere in this position. So the way we determine the center point is by adding the radii together. So we're working from two known points. The only two known points on the drawing is the center of the radius 30 circle and the center of the radius 50 circle. So if we take that center and we add on 80 millimeters, we can draw an arc, and we know that that center of this radius will be on that arc somewhere. So if we take 80 and we add 30, we get 110. Alright, I have to use my longer ruler. So I'm going to set my compass to 110 millimeters radius. 100, 110. And from that point, the radius 30 circle, I will draw an arc. Now the center of the radius 80 arc is going to be on that line somewhere. The other point we can construct from is the radius 50 circle's center point. So if we take 50 and we add on 80, we get 130. So we set our compass to 130. We place it on the center of the radius 50 circle, and we draw an arc. So now we have a center point, and we know that each of the circles are 80 millimeters away. So now all we have to do is set our compass back to 80 millimeters, which is the arc radius. And we should then be able to draw an arc between those two circles that has a radius of 80 millimeters and is tangent to both of the circles. All right. So if we decided that we wanted the arc to be in the downward direction, then we know that if the arc goes this way, then the center of that arc will be above the arc. In that scenario, we have to subtract the radii of our circles. So let's try that out. So if we take 80 minus 30, we will get 50 millimeters. Let's set our compass to 50. And from here, draw an arc above where we're going to be drawing this arc. It's going to go downwards. Alright, then we need to, let's just extend it, because we don't really know where it's going to go. We take the 80 and we minus the 50. That leaves us with 30, so we set our compass to 30. And from this point, we draw 30. Okay, so from there we can see those lines are not intersecting. So in other words, we can't draw an 80 radius arc tangent to both of these because the arc is too small. So let's increase the radius of that arc. Let's say the arc radius, let's say is 120, for example, for the upper one. So then we would take 120 minus 30 will give us 90. We set our compass to 90 and draw that arc. Oh, might be going off the page. And we take 120 minus 50 will give us 70. So we set that to 70. We just made it at that point. And we said our arc radius is 120. So we set our compass to 120. Put it on that intersection point. And now we can draw an arc that intersects those two circles but is also tangent. As you can see, that radius of 80 would have been too small to be tangent to both the circles as they're too far apart. So this one is a radius of 120. This one is a radius of 80. So we either add the radii together if the arc is going upwards towards the circles, or we subtract them if the arc is going away. Alright, the next exercise that I wanted to show you is on page 22. And this is a 4-center method for construction of an ellipse. As you know, an ellipse is like a circle that has been flattened out, and we use those a lot in our symmetric drawings because all our circles are looked at an angle, so therefore they become ellipses. So this is a construction method for an ellipse. But it doesn't give you a true ellipse, it gives you an approximation of an ellipse because it actually has a larger radius and a smaller radius on the ends. So it's an approximation. So the construction method goes like this. We start off with, let's just lock this into position. And we'll start with our axes. All right, so let's draw a nice large ellipse. Let's say it's 120. The major axis is 120. The minor axis, let's make it maybe 80. Point C and point D. So we want an ellipse that goes through those two. So the first thing we'll do is draw a line from A to C. Right, so we've got to use O as the center. Put our compass point on there, set it to 60 millimeters. Point B, and construct an arc from B going all the way up to point E. Alright, from point E we've got to do a construction. We put our compass on C and set it to the radius CE. And take that down to the line AC to give us point F. Now between A and F we have to draw a perpendicular line. So as you recall, we have to set our compass to something larger than halfway. We draw an arc from either side. And drawing the intersection of those two arcs to find point G. So point G is where that perpendicular line intersects with a B. All right. If we now extend this line further down, we'll find that it intersects with the line CD at a point which we will call J. Now in my case it's just J is just slightly below D, so it just depends on the geometry of your ellipse. Alright, so what we have now is the center point J and G. That's the centers of the large radius and the small radius. So let's just measure the distance OJ and mark it off on the other side. And that would be the other center point. I think something is slightly off here. Yeah, D is supposed to be down there. So that crosses point D. Let me check if my other axes are accurate. Slightly off. Alright, so I was measuring from the end when I should have been measuring from that point there. Right. So my construction is going to be slightly off. So we've found the center point there and we've taken it across to the top. What we can do is the same here, transfer G to the other side of the axis. Call that H. And that one will be C, I think K. That's K. So if we use those as our center points and we set our compass to that distance, I just want to make sure. Alright. I measured a little bit wrong, so I'm not going to actually reach point A, but let's go with point B. There are two minor axes, a smaller radii. So if I put my compass now on to J and I set it to point C, it needs to be lower. There we go. I just made a slight mistake there. There you can see our basic ellipse construction. Those are the two sharp radii and those are the two large radii. So just to recap, we will draw our major and our minor axes. Make sure you draw it accurately. We place our compass on O, we set it to B. We transfer that dimension to E. Then from this point C, we will then transfer that dimension from E all the way down to F, which is the line that goes from A to C. Then we have to construct these arcs, draw the bisector to find point G and point J. We will take that distance, OG, take it to the other side to find H, and OJ we'll take to the top to find K. Those then become the radius. J is then the radius of the circle at the top. We can draw that arc, and K is the center point of the radius of the circle at the bottom. G is the radius of this circle, and H, center point of the radius of this circle. And there we have our ellipse. Construction of the ellipse. The last thing I want to show you today is to find the true length of a line on page 26. You can go and practice all the other exercises of constructing nuts and bolts and drawing these intersections, but I'd like to just show you two different methods for finding the true length of a line. Now this is important because sometimes none of our views in orthographic projection, which is a front view and a side view or a top view, none of those views show the line in its true length. So for example, this house has a pitched roof in both directions. So line AB going in that direction there, from the top view, it's sloping downwards, so it's longer than that distance. From the side view, it's sloping away from us, that's longer than that as well. So we have to find that true length. So if I had to do a quick construction, and let's draw the rest of the house down here. Let's draw some instructions. So what we have in this view, let's actually draw the center of the house, the roof. Let's draw it here. And the pitch of our roof will be running like this. So this is a top view of the house, the roof of the house. I'll just draw these lines a bit darker. Looking at a house with a pitched roof, and that is the top view. All right, now we're going to look at the side view of the same house, which then has the roof pitch like this. The rest of the house will move downwards in this direction. I'll just draw the bottom of the house. So line AB is the line that we are trying to find the true length. So the most common way to do this is to draw a projected view which is perpendicular to that surface, which means this surface here. So an auxiliary view, in other words. There's the surface. If we want to know the true length, we always have to look perpendicular to that. So if we had to construct, let's just take a point here and construct a perpendicular line just using my protractor. So that is the direction there that we want to look at this surface in order to find the true length of AB. All right, so now we can draw that bottom line over there. Let's call that point C. Let's draw that. The true length of that line is 31 millimeters. So if we mark it off 31, 15 and a half is the height. So now we just draw a perpendicular or a parallel line from that point along that axis. And we've got a center line there, which is now perpendicular to that line. We can draw that roof surface. In other words, this is A, this is B, and this is C. We're drawing it looking perpendicular at the surface. So the view is in that direction on the surface. And that is what we would see if we turn it sideways. Now if we had to go and measure the length of AB, yeah, we get 27 millimeters. So that is the true length of the line that's reflected there. Okay, that's the most common way to do this construction. The other way is to take this line AB with your compass in the top view and then draw an arc down to a horizontal, obviously using your drawing board to keep everything perpendicular. We then take that line downwards and we will join this point to the top. If that was B and that is A, then this is B dash, and This would also be 27 millimeters. 27 millimeters. To measure from there. Two methods of constructing to find out the true length of a line. Alright, so that's all I'm going to be showing you in this exercise. Please make sure that you do all the exercises, that you practice these exercises as I've shown you, all the way from up to page 26 from page 20. Practice all of these construction techniques. As we get to page 28, 27, 28, we're going to be starting with orthographic projection next time, and you will need to know how to draw all of those constructions by then. And that's all for today.